All right, I'm Doug. I'm originally from Seattle, Washington, but I'm currently traveling around Europe as a digital nomad with my family. And I wore the most Microsoft-y shirt that I had. It's close. All right. A little bit about me. I'm doing freelance developer relations, so I help companies talk to developer communities. And I've worked in performance for a really long time. So I work at the web, apps, native apps. I talk about images and video. I wrote a book called High Performance Android Apps. If you want to download it, that's the URL. I'll post the slides up to you later tonight. And if you ever have any questions about performance or want to chat, I'm the only Doug Sillars on the internet, so I'm really easy to find. Before I start talking about performance, how many of you look at this walkway that's nailed onto the side of an L? And when you think about walking across it, you kind of get a pit in the bottom of your stomach. That's kind of terrifying. So we walked across that as a family. My 6-year-old jumped across the whole thing, so it had this rattling effect, which really added. Jumped across the whole thing, so it had this rattling effect, which really added to the whole ambiance while we walked across it. So about 2 years ago, Ericsson did a study, and they put sensors on people's heads to measure stress responses to different actions. And they found that queuing up for a line raises your stress level. They found that imagining walking across the edge of a cliff raises your stress level. But interestingly, they found that a slow mobile experience is actually more stress-inducing than standing on the edge of a cliff. So if we build experiences that are slow, our customers feel like you were all feeling about 90 seconds ago. And that's not really the feeling you want people to have when they're visiting your content. You want them to be happy and engaged and pulling their wallet out with a credit card, right? So Google found that a 3-second delay causes 53% of people to abandon a mobile website. Another study found that for every 500 milliseconds they added, people were more frustrated, less engaged. Walmart and Amazon found that people spend less money. And then 4% of mobile users admit to throwing their phones when there's a slow mobile experience. So this is really a bad thing, and we really should do everything we can to improve it. So that's why I'm here to talk to you a little bit about the stuff that I do when I look to improve mobile apps, mobile websites. So the trick is everybody's demanding like these great, immersive, rich experiences that are fast. And if you're downloading all this rich and immersive content, sometimes getting it downloaded fast can be a problem. So let's walk through some strategies that we can do. Another thing to think about is that cellular networks can be really high latency compared to the connections that we have at home when we're connected to Wi-Fi. If you're on a 3G connection, it can take 2 seconds before the connection is established. This isn't even TCP/IP. This is the phone saying, "Hey tower, I want to connect," and start connecting. Okay, they start, and then all of a sudden after 2 seconds you get TCP/IP, and then packets can be sent. So you get this really long delay. These are cool. Of like 2 seconds, and it can be even a quarter of a second on 4G. And then every round trip is extremely slow, high latency, just because we have this magical thing in our hand that's talking to a tower on top of a building nearby. It just adds a lot of latency. It's not as fast as having Wi-Fi in the same room or the same building. The other thing to think about while you're building an app is when you make a mobile connection. This is a tool that I helped build when I was at AT&T. And these are packets coming in and out of my phone. And this is simulating the radio being on. And because there's this huge delay to turn on the radio, all carriers keep the radio on after the last packet because maybe more packets will come in. But if you leave the radio on too long, you're going to kill the battery. But if your app is, usually it's on for like 10, 15 seconds after the last packet is sent. So if your application is doing things like frequent polling, or if it's sending a keep alive, or sending a heartbeat or something like that, your app may not be letting the radio turn off, which can lead to a severe battery drain. And in some of the newer versions of Android, you've probably seen this. You'll see an app that says, "This app is draining your battery," right? And if your app is doing lots of pings and turning the radio on a lot, it may be that it may your phone may say your app is draining the battery, and that's really bad because obviously people are going to uninstall your app if that happens. So what I want to talk about today is some of the tools that I use to identify issues in mobile apps and mobile websites, and then some of the best practices that we've learned from studying lots of different web pages, lots of different apps, and then see some of the results that come from it and why it's important to do these sorts of things. So the tool I helped build at AT&T is Android and iOS. It's called Video Optimizer, even though it does mobile apps. That's just marketing for you. Sometimes they change the name. And then for the web, I use a tool called Webpagetest, which is a really great tool to look at how web pages can be loaded and improve the speed. Has anyone used either of these tools? Webpagetest? No? Awesome. Well, these are really awesome tools, and hopefully that will get you somewhere with improving the speed of the products that you're building. So with Video Optimizer, it's really easy. You plug in your Android phone, you select the type of collector. You can change the speed, so we have a way to slow down the network that you're testing on. This is really important because here in London, you may have great 4G in most of the places you're at. I see a lot of heads shaking. It's true. There are places in big cities where you get no connection. I spent a month this summer in West Cork, Ireland. The longer you say west, the further west you actually are. That's what they told me, at least. We were 2 hours away from the city of Cork. And our Airbnb said it has Wi-Fi. No problem. What they did say is it's connected to a 3G router that really only has edge coverage. So for a month, I was on edge. It was really eye-opening to see what worked and what didn't work. So it's important, if you can, to test your app on a slower speed just to see what's going on. Facebook used to have a thing called 2G Tuesdays, where they just turned down the Wi-Fi every Tuesday down to 2G. You had to see what the things you were building looked like when you were on 2G. You record the video, and then you're recording a network trace. So we're recording a network trace on the phone. And the way we do that is we have a VPN running. You can see the little key right there. So here I'm testing a real estate app in the States. I'm collecting all the packets through my man in the middle on my VPN. I test the whole app. I want to see what I want to do. I run the whole app, and then when I'm done, I press stop. Now I have a PCAP file that's copied over to the computer, and I can look at it. Anyone here use Wireshark? Right, lots of hands. Wireshark is awesome, but you learn a new thing every single time you use Wireshark. Am I right? Like, it's just this crazy tool that does everything, but as a newbie to it, you're like, holy, how do I make this work? So we tried to make our tool really easy. We have 40 best practices, and if you have a green check mark, and if you have a red X, right, and 40 best practices, how to optimize files, connections, HTML, security, and video. I'm going to walk through a bunch of these as I get through the talk on ways to improve some of these fixes. Webpagetest is a very similar tool. It's a webpage, webpagetest.org. You plug in a URL. You can test all around the world. In this case, I'm testing in Dulles, Virginia, because in Virginia, they have a bunch of Android and iOS devices. Actually, they're not emulated, they're real devices that will test, that you can run tests on. I think that's the only place with mobile devices, but they have like Chrome, and you can emulate, mobile devices all around the world. So you can see what your site looks like in Singapore or in Sydney or, in the States. You can change all sorts. These are all parameters that you can muck around with and change the parameters of your testing. And then once you go, you run your test, and you get results, right? You get some grades, you get load time. So this page that I built takes 19.6 seconds to load on a cable connection, right? That's really, really slow. And the reason is because it's 11 megabytes. I just threw a ton of images on it. It takes forever for this page to load. But you get all sorts of great information about what you can do to improve the load time of your web page. Same idea, but faster and better. So what can we do to optimize content delivery? One is to reduce the number of redirects. The first time you hit google.com on your mobile phone, if you type in google.com, it does a redirect, a 301, to www.google.com, which redirects to the HTTPS. And if you look, that adds 2 seconds to the initial load time of google.com. These, if you go a second time, they're cached, so the second time you go, it's a lot faster to load. It's still really fast to load. It's still, even with 2 seconds of delays, it still loads in 3.5 seconds. So they've done a lot to optimize it, but it's just interesting that they could easily remove one of those redirects for the first visit. They could have google.com redirect straight to HTTPS, www.google.com, and remove one of those. And on this test, Webpagetest gives them an F, which is really interesting. Some of these things are, they affect actually really big companies as well. This is from Video Optimizer. It's a music app, and so every single time it downloaded the album art, it did a 302. So my app made a request saying, I want this album art. The server said, no, go to this other server and download it from over here. And it turns out there were actually 242 redirects in like 10 minutes. It added like an extra minute to me actually using the application. It made it so visually slow that it was awful. I had coworkers coming to me, have you seen how slow this app is? And I said, I know exactly why this app is slow. I'm going to help fix it. To make matters worse, 33 of those redirects ended up going to a 404 error, so just the images never loaded. So I mean, obviously when you're building an app, you want to make sure that you don't have 404 errors when you're doing that, so this is a great tool to help you find those things. I once found an app that had a lot of 404s, and I reached out to the developer, and they were using 404 counts as their analytics. So every single time you hit a page, they had a fake image, so they knew this. There are free tools out there that will do that for you a lot more efficiently, but okay. Does anyone know what an HTTP 418 is? It's my favorite HTTP response code.
People?
I'm a teapot. Yes. So it goes back to the days when people connected cameras to see if there was coffee in the coffee machine back in the break room. And so for April Fools, they actually added this to the spec, HTTP 418, I am a teapot. And it's like the ultimate image joke, because as a developer, the only person who's ever going to see this is someone who's actually looking at HTTP headers, which is other people like us looking for. So it always makes me laugh when I see it. Interestingly, NPM was doing a migration, and they had a couple edge case things that might cause an issue when they were migrating. I think they were migrating to Cloudflare. And 5% of people were, at the day after that migration, were getting 418 I have a teapot errors while they were trying to use NPM. You know, I talked to the guy who was having that. They didn't expect to see any because they used I have a teapot. So. The other one that just came out is, and there's a website that has cats pretending to be all of these different things. They just announced 425 too early, so there's probably like a sleeping cat out there that uses HTTP 425. All right, so what's another thing that can slow down content? Third parties can get in the way. So this is an app that I was testing. It's in the States. It's a video streaming app. I said, I want to watch Adventure Time. And I got an ad. And we all kind of hate ads, but that's part of what happens when we're on the internet and apps these days. But this is the screenshot from Video Optimizer. And right here is where I said, hey, I want to watch this movie. And this is throughput. So this is showing an ad being downloaded because videos are really big, right? So the throughput goes through the roof. But if you look at these first 2 seconds right here, there's a lot of packets, but not a lot of throughput. That's obviously not the video, so what's going on here? And it turns out that these are all the connections that were being made. And that's the video, we know, because it's really big. Even though it's sent over HTTPS 443, it's 5 megabytes. That's got to be the movie. So there were 14 connections made beforehand. They're all analytics. So it was all like, hey, how's the video playing? Did the video start? They added so many different analytics, just like Heisenberg, right? The more you observe a system, the more you actually, modify the way it behaves. And it was adding 2 seconds before the movie could download, 4 seconds before the video could play back. If you're on a slow connection, it was as much as 12 seconds, which means people are abandoning, right? After 12 seconds, you're like, I'm not watching this, this is a waste of my time. The other way we can speed up content delivery is, when you buy something from Amazon, and you open it up and you pull out like 15 meters of brown paper and you find out that you ordered a pencil, right? We're sending things that are super huge over cellular networks to these little tiny phones, and if we send it smaller, it would get there faster because smaller things download faster. So what can we do to optimize the delivery of content and not be like Amazon and have these giant boxes that show up on our doorstep? If we look at the average web page, and we're going to use the average web page as kind of an analogy to the average app. It sort of fits, but it's about 25% text files, it's about 50% images, it's about 25% video. We'll just go with those numbers. It's just an analogy to look at what we can do to optimize these. Same app that I was talking about earlier. Sometimes when you find one app, you get lots of use cases just in one application. In this case, this one had a bunch. This screen is populated by a JSON file, 130 kilobytes. It lists all the information, right? The name of the TV show, it has a link to the URL to populate these spots here. And the faster this thing downloads, the faster the request can go out to get all that information that fills this page. But they didn't compress it. So it's 130 kilobytes over the wire. If they compressed it with gzip, it'd be 16 kilobytes. If they use Broccoli, it'd be 12 kilobytes. That's one round trip. instead of like 5 or 6 round trips to download that content, right? And so if you have 100 milliseconds round trip time to each one of these things, you're adding about a half a second to getting all the content before you can start requesting all the stuff that shows up on the screen. You're just delaying stuff being delivered. So gzip, yeah, on mobile devices is like 1 millisecond of latency, roughly is about the same, but it's just a newer algorithm, so it just squeezes out that like couple extra percent of savings. The other thing is Google made, all of the Google compression scientists are in Switzerland, and so they named all of their compression algorithms after bread products. So this is bread, or small roll. I don't know, I don't speak very good German, but the small roll, you can find them in the grocery store or go to Switzerland. Images, what can we do to make images smaller? You know, a picture's worth 1,000 words, images are all over our apps, they're all over web pages. If we can make them smaller, obviously stuff will get delivered to the customer faster. So what can we do to make them smaller? Scalable vector graphics are awesome because they're text files, essentially. You put vectors into an XML file. They're infinitely scalable because they're vectors, right? They don't get pixelated when you make them really, really large. I found this Facebook logo on a web page in Brazil, and they messed up their scalable vector graphic. If you look at how much scrolling you can do in the XML, and you look right here, there's this Adobe Illustrator, built it in Adobe Illustrator, they saved it, and Adobe Illustrator added 1.3 megabytes of Adobe Illustrator cruft to the text file. So I went into the XML and just highlighted it and deleted it and resaved it, and I got it down to 900 bytes, which is what, like 99.9, maybe 49 savings. I haven't actually figured it out. And then of course, since it's XML, you can gzip it, and it's like half of a kilobyte. They have 5 of these files on their webpage, so which kind of just shows you that you probably need to test when you push stuff live to production. I mean, maybe it passed a test. I mean, the image is loaded, but you should probably also look at how big those files were. 5 megabytes when it should probably only be 2K. You can see the download speed or something like that. This is an app that I was looking at. Again, there's like 6 pictures of Frank Sinatra right here. That's the dimensions of my phone. And if we look at this little image down here in the bottom left-hand corner, it's 1.8 megapixels. It's 1500 by 1200. And it was 1.5 megabytes. Now you can imagine you have 6 images, you're trying to download 1.5 megabytes each. That's going to take a really long time to download. So what can we do to make this image smaller? And in fact, there are a lot of things we can do. The first thing we can do is say, well, the screen is 1440 wide, let's just make it 720 wide. We're making it about, a quarter of the size of the original image, and you can see it from 1.8 to 0.4, that's about a quarter the number of pixels. It looks like that. So it's going to fit perfectly right there. And in fact, it's 75% smaller. If we take out 75% of the pixels, that sort of makes sense. Another thing you can do is image quality. And Google recommends through their Lighthouse testing that you make every single image 85% quality. So you just, in Photoshop or whatever, you just take the slider to 85% when you save it. And that's what the image looks like at 85% quality. You can't tell the difference. If you zoom in to the, you can tell the difference. That's the difference if you really look very, very carefully. If I do that, it goes down to 500K, 64%. The awesome thing is I can combine both of these. And now this image, when I do 85% quality, resize it, is 90% smaller. It's 175 kilobytes. That's going to load way faster. It's going to be efficient on just about any mobile device, almost any mobile network. If you look at the HTTP archive, which is looking at 500,000 websites, a full 1/3 of the internet today is not using 85% quality on images. So this is something that, I guess 43% are, if you want to look at, the glass half full approach. But there's a lot of room for improvement. There are a lot of apps, there are a lot of websites that aren't doing this, and it really makes images and makes the images a lot smaller, which allows for faster load times. Lighthouse actually says that for the median site that fails here on 3G, it'll load 2.8 seconds faster. And we've seen that 2 seconds can make a huge amount to how long people stick around. Also 420K less data. So pretty big performance improvement just by changing the quality to 85%. There's some cloud tools that will do this. One of them is called Cloudberry. You upload your image and you just change, you upload the full-size image. And this is a link to the full-size image, but then I add these parameters to the URL. This makes it quality 85, this makes the width 720, and it generates that same image I was showing you earlier. It's kind of cool. But we can actually do better. There's another algorithm that measures the quality level that you can decrease it to before our eyes can tell the difference. It's called structural similarity. There are a couple different algorithms that do it. So you just set Q auto, and we save another 50 kilobytes. So that's getting, probably taking me down to like 78% quality or something. But it does it automatically. We don't have to think about it. We just tell them the parameter. There are lots of tools that will do that for you. And then finally, because we're on Android, we can save it as a WebP. WebP is a Google format, right? It works in Android, it works in Chrome, and now we're down to 95% smaller. We got this image down to 84 kilobytes. So that's pretty impressive, down from 1.5 is what we saw in production. The great thing about WebP, I did mention that it is a Google thing, right? It was developed by Google, it works in Chrome, it works in Android, but really interestingly, it's now launched in Edge. So thank you, Microsoft folks who are here. So we can get it in Edge. And they're working on it. It's actually active working on it. This tweet is from last week in Firefox, and they're also working on it in Safari. So this algorithm that saves even more, right? We got another 2 or 3% by going to WebP is soon going to be supported in all major browsers, all major modern browsers, which is pretty exciting. The next trick is resizing images. These are all of the Android images that hit Akamai in one day. The size of the box is how many, so these are all Samsung devices, right? So there are a lot of Samsung devices, or quantity, these are all S7s, S8s, this is about a year ago. The color is how fast the CPU is. So you can see those new Samsungs, they're pretty fast. There are a lot of devices that have very low market share that are really, really slow. I'm sure you guys all know about Android Go devices. You can buy one right now at the Carphone Warehouse. I think it's 60 pounds. Brand new, runs Oreo 8.1 Go because it has such low memory and it's a slower device, and you have to look to see what your app looks like on these slower devices. I think it's 512 megabytes of RAM, right? So it's just a really low power processor, low power devices. It's important to see what your images or your apps even look like on those devices. So what do you do to optimize images? On the web, you can generate a bunch of images, and for different widths, you serve the different size image. And I've got a demo of that, so let's just do a quick demo here. This is my web page, and what happens is when I make the screen smaller, it automatically downloads a different size image. And I go from color to sepia so that you know that a new image is right. Those are all 25 kilobytes apart. So, for the smallest, tiniest little device, you get a 25 kilobyte image. You come up to the biggest device, you get a 200K image, but it looks beautiful for everybody, and you're not wasting data for those folks on smaller screens. And this is what it looks like. Whoa, I'm right button. That's what it looks like on the HTML. And again, I'm using Cloudberry. I'm setting a new width for each image dimension, and then also you can also see there's a sepia parameter to make it sepia, which is kind of cool. So when an image is loading, another thing you can do to get the perception that things are happening is you can load a blank SVG in the background. So this is Google image search on my phone. I'm searching for cats in costume, as one does. You get this green placeholder for the cat dressed up like an alligator, a pink one for the cat dressed up like a bunny. People know an image is coming, they're SVG, so they're super tiny, and then when the image comes in, it replaces the image that was going to be there, or the preview image that was there. You can do fancy things, so this is an SVG representation of the waterfalls, right? So there's a little bit of white where it just is a little bit fancier. Maybe it adds another 200 bytes to the image, so you can do that. So a lot of fun ways to do that. And that takes us to lazy loading. And so the idea of lazy loading is on the web, most people don't scroll on the web page. They load the front web page, they may scroll down one viewport, but after that, they don't scroll anymore. And this is actual data, right? People stop scrolling when you have a really long web page or a really long app. So what happens if you have a web page like this, and you just don't load those images? or you don't load the images that are below the fold in your app. You just made this load way, way faster because you're only loading 2 images when you're rendering that first view of your app. And so it's really easy to use lazy loading. Then once you see them scrolling in place, you've got a placeholder image when they scroll in place, and then you make the request for that image. But you've got all of the content there faster because you're not loading those 4 images to the bottom of the screen. Lazy loading isn't used very much. 60% of the web isn't doing it. There's some cool stuff in Chrome going on right now where you can actually so when you load a web page, this is the first viewport, and you can see that images way down below are loading first before the stuff up here loads. The text is cascading down. Behind a flag, you can lazy load all the images, and you can see that the images are loading in order as you might scroll. So this is actually coming into Chrome pretty soon. This is in Canary right now, which is pretty exciting. Animated GIFs are really, really awesome. This is a video I took of my goat back in Seattle. This is Nora. It's 1.4 megabytes. I made it a GIF. And the problem with GIFs is GIFs don't have compression through the time dimension. So it actually got larger when I made it a GIF. So video can compress through the dimension of time. Animated GIFs are actually just a flip book of static images because GIFs were invented in the 1980s. So what can we do to make that GIF faster? We can make it 256 colors. I can strip out the audio channel because there's no audio in GIFs. I made it 93% smaller. And you can load it as a video, autoplay loop muted. You have to have muted in Chrome for it to autoplay. That protects us in meetings when we're browsing the web and the video plays and we don't want the sound to blast. You can also put it in the picture tag. This will play on Safari. It won't play on Android today, but you can actually play it on people who are looping in the picture tag. You can do an animated web piece. And this is 250 kilobytes. This is 3 megabytes. That's 3.8. So if you did this on a web page today, it would be great for your Safari users. Not so great for your Android users, but it's still a little better. Finally, I've got a couple more minutes. I'm going to talk really quickly about optimizing video, things we can do to speed up video delivery, because everyone wants to deliver video. Video's like, what is it, like 80% of the internet in evenings, right? People are delivering a lot of video, and people get pissed off if video's slow. And when video's slow, when things are slow on their phone, people blow their phones. Important video metrics: did it start playing? Did it stall? And did it look good? So we'll walk through a couple of them. I'll probably run out of time, but then I'll stop and then we can talk about it later. This is data from Q1 of this year. 2.4 billion views of video failed in Q1 of this year. About 800 million hours of video playback completely failed. This is from an analytics company. Some of it's due to stuff like this, right? We've all seen that. The problem with this is, of course, when I go to Amazon Prime for America, it says these are the videos you can't watch because you're in the UK. In this case, I had to go to the page, download 231 requests and 3.1 megabytes to find out that I couldn't watch it. It's kind of a little nicer to say, hey, you can't watch that, rather than go through all this mess. But what about the ones that failed to start? And what we find, what research shows, is that everyone will hang out for 2 seconds, but after 2 seconds, people start abandoning at about 6% per second. It's different for short videos. People abandon short videos a lot faster, so if it's a cat dressed up like a shark on a Roomba chasing a duck, after 3 seconds you're questioning your life choices, and you can stop watching the movie. But if it's a TV show, you'll hang out a little longer. You're going to spend an hour watching a TV show, so you'll hang out longer. This is that same video, right? So this is the ad downloading, 30 seconds. They didn't preload the movie. So the ad stopped, and you had to wait another 10 seconds with a spinner to wait for the movie to come down, after you waited for the ad to come down. So preload the video, right? The network isn't doing anything. Well, the ad's playing, download the movie. So that once the ad ends, you can watch the movie. Preload that video, and it makes sense. On the web, you can use preload equals auto. That can be really bad. This web page downloads 24 megabytes of video, whether or not you press play on your mobile device, right? So be careful with it as well. Last thing I'll probably get to before I get pulled off the stage is background video. There's a lot of evidence that this really increases engagement by like 80%. People love having background video on their web pages. This one made a mistake. I mentioned it earlier. They downloaded audio for a silent video. So it just takes longer for the whole thing to download because the file is 5% larger than it needs to be. to save bandwidth, remove the audio stream, which is really easy to do. And then the last background video, and on the web, if you're gonna hide the video for small screens, don't download it. So it downloaded the video but didn't show it on the screen for your mobile device. It seems common sense, but I see it on so many different apps, so many different web pages where they don't show the video, but they download it anyway. So it's hurting your plan, it's hurting your data, it's draining your battery. So this is another one. This is a background video that you will never ever see. I sat on this web page for like 5 minutes and on desktop, and I never see it. And the reason is, it's 33 megabytes, it's 27 seconds long, and it's 2500 by 1200. This is ginormous, it's 10 megabits per second. The other important thing about this video is Bob Ross is also a photographer. Right? All right. So it's important to resize the video to something reasonable. This is what's served on desktop and on mobile. It tries to download this video on your mobile device, which is really disgusting. If you rename the file to 720p, renaming the file doesn't re-encode the file. As much as we'd love for it to be that easy, that doesn't do it. It is new. But I resized it, and 1080p is 10 megabytes or 8 megabytes. You get these smaller ones. That's a lot more reasonable for desktop for the web, right? Or for desktop or for mobile. And then the last example I want to show you is video third parties. Who loves TED Talks here? Anyone, right? TED Talks are awesome. There's this share button. You hit the share button, it gives you a div. You copy that div, you slap it onto a web page. No problem, you got a TED Talk embedded. This is a web page that just has this on it. And what happens is it actually downloads the entire movie. One line of code, yeah, what div? No big deal, right? And it'll be 32 megabytes and 118 requests to my web page. So if you add a third party, whether it's a YouTube embedded link, whether it's a TED Talk, do a quick audit just to make sure that it isn't drastically causing issues with your web page or your mobile application. All right. And so with that, in conclusion, you want to optimize your images by making them smaller, quality format, sizing, lazy load, and then video. Only download video that's going to show up on the screen, strip out the audio if it's silent, resize them appropriately for mobile devices, audit your third-party videos. And I didn't get to talk about streaming, but if you guys are interested, we can talk about it later. And so with that, thank you very much, and take questions.
That was really interesting, though.
Thank you.
Any questions? Anyone? Down there? No? Nothing there?
Yes. Yeah.
I just had a pretty simple one, which is, how do you convince business people that this stuff is important? Because I've had a lot of cases where you take this kind of performance stuff to people,
Right.
but they just don't care.
I mean, I guess there's always like A/B testing, right? If you did an A/B test and you had one like, it's going to resize this video so it's something a little bit more reasonable, and the page or your app loads X seconds faster, maybe you'll see more engagement from those or more. I mean, that's a great way to do it, is actually test it on your own content just to see how much faster things are. It's weird that they aren't interested, because usually a lot of these are pretty trivial fixes.
The problem is usually it's not these kind of fixes that they're bothered with. It's kind of, we want to remove this third-party library because it doubles the size of the download.
Exactly, right. And then it's more of a, you've got to fight whatever team wanted to add that third party in the first place. Going back to that example that had 14 of them, when I presented that to their leadership, they're like, oh, yeah. Maybe that is a few too many. Maybe we'll go down to 8. I don't know what they ended up doing. It got a lot better though. It's a hard thing, and like it's hard to even say let's A/B test 5% of our people without that library, right? That's tricky because they may be really angry if you do something like that. That's where the performance sort of gets into the trying to figure out why it's there, and maybe find an alternative. Oftentimes there's an alternative library that'll do almost the same thing that's a lot lighter. If you can do that, that would be a A/B test. Like here's one that's not a megabyte but 100K, and it does exactly the same thing and is going to be faster.
Anyone? Yeah? Your name, sorry?
So the stuff I saw tonight, and most of the time, is a kind of testing that's quite exploratory, and you seem to sort of notice that there's something wrong with a site and
Yeah.
start working from there.
Right.
Have you seen successful strategies to catch these things before they happen, ideally, and to do I don't know if regression testing is the right word, but to continuously check performance, not
Right.
just run it as a one-off?
So I know that the video optimizer tool right now, they're doing a lot of automation stuff right now. So their next release, they're going to be, if you have automated tests, you can run this with every Jenkins build. So you can track it over time. If the data goes up, you know, if you run the test as 1 megabyte, and all of a sudden it's 2, you can say, oh, something happened, what's going on? And the same thing you can do with Webpagetest. There are a lot of tools out there where you can put this to, every time you have a new build, it'll run a test. So you can see as things change, you can constantly monitor each build to find it beforehand. And obviously it's better to find, when I was doing all this testing, it's already launched and in public, right? So I'm finding the stuff that's already affecting customers, but if you can do this obviously before launch, catch it and fix it before it goes live, that's huge. So we've been lucky enough to catch some of those as well.
Anyone else? No?
Okay,
Thanks very much, Doug.
Thank you.
Now we're going to switch to the second speaker. Thank you. You ready?
Yeah,
Yeah.
cool. Good.
Right, so we have Simon who's going to talk about the UI research strategies for SwiftKey, right? So please welcome him with a big applause.
Perfect. Great. So I'm one of the UX researchers here at SwiftKey, so I'm going to be talking to you today about how we use UX research to unlock insights that we don't get from our automated testing and from telemetry. So I've been a UX researcher here at SwiftKey for 4.5 years, and I work across the entire product portfolio, if you like. So that includes early research that would inform our strategy, but also as we pick the features that we are going to add to our app, working on the implementation of that with our design team as well. Before that, I was a PhD student at Edinburgh University, where I had the chance to build voice-driven, speech-driven interfaces for older users, and working out how to make those more usable for older users, so that was cool. I'm going to be talking about the SwiftKey keyboard today, so just in case anyone's not familiar with SwiftKey, it's a popular third-party keyboard on Android and iOS. There are over 300 languages available on Android. So as you can imagine, SwiftKey's invested a lot of time into learning about how people use language in different languages, and how we can improve that over time as well. So SwiftKey, as you can see from our Play Store, there's quite a lot of users using SwiftKey, so whenever we do make changes, we want to make sure that those changes are right for those people. Cool. So at SwiftKey, we invested in evolving our language prediction technology. Originally, we were using Ngram-based models, and I'll show a video that explains that after. And this evolved to using neural network-based models. The reason we did this was because we believed that neural network-based models would offer more accurate next word predictions for people typing on SwiftKey, because neural network models had more context of the words that you've been using. I'm going to show a short video that kind of explains the difference between our Ngram model and what changed whenever we transitioned to neural network models. imagine, we didn't get there overnight. It took a lot of work from a lot of engineers and a lot of insights we needed from our users to make sure that we were heading in the right direction. And today I'm going to be talking about not only the automated tests that we use to measure prediction accuracy, but also what UX research methods we could use to unlock additional insights about our language models and how people were using them. So the engineers at Swiftkeys developed an internal testing tool. The tool could let them run automated tests on different types of language models, and would then calculate which one of those models was the best at predicting the next word in the text sentences that it was using. So into this testing tool we fed data from Twitter, so this is publicly available data of what people had typed and different language model types. So we had a standard n-gram model, but also neural network language model. And the tool would take all of this and it would compute which of the models was best at predicting the user's next words. So the result from the internal testing that we conducted showed that the neural network language model was actually significantly better at predicting the user's next words. That was great news, that's what we wanted to hear. So the next step from that was to roll it out to a percentage of our existing market users. And what we wanted to see there was, would it have any impact on some of the metrics that we care about? And in this case, we wanted to measure this by observing user retention between people who were using the n-gram model and people who were using the neural network model. So what happened when we did that was that we didn't observe any statistically significant difference in retention. Both seemed to be about the same. And that was really disappointing because we invested so much time building the model, we tested it, we knew it was better, but for some reason it just wasn't showing up whenever we sent that to the market. So how can UX research help us understand why this would happen in spite of the language model's prediction improvements? So that's what I'm going to focus on for the rest of the talk. So first of all, UX research, what is it? It's a systematic investigation of users and their behaviors and their needs. So there's lots of different ways that you can observe and measure those things. There are qualitative research methods, so things like bringing users in, interviewing them face-to-face, observing what they do, measuring their behavior, and gathering insights from that. But there are also quantitative methods, so you can administer surveys on users, or you can run A/B tests and understand at a more quantitative level what their attitudes might be. So I recommended for this project that we would use a two-part method, because I believed that we needed both attitudinal and behavioral data from our users to try and understand what was happening when they used the neural model versus the n-gram model. So the first phase was a quantitative phase, which allowed us to collect attitudinal data from users. And the second phase was a follow-up qualitative phase to help us understand the thinking and the behavior behind the attitudinal data that we collected. So I'm just going to talk a bit about attitudinal data first. So this collection of attitudinal data allows us to measure how users are thinking and feeling about your product. It's usually measured against attributes that we care about. So whenever we administer a questionnaire to users, we can learn what attributes of using our products impact their overall perceptions of usability of the product, and that can be a positive impact or a negative impact. Data is collected from users after they've had a chance to use the product in the real world for a number of days, usually, a long period of time. So that's one of the biggest differences between this and our internal testing, which is usually conducted on small bits of data that's been collected from public websites. Cool, so the sampling method for this project, so we built a neural network model for English US first. So I wanted to sample users who only type on Swiftkey using English US. Swiftkey lets you type in up to 5 languages at once. So if we select users who use English plus 3, 4 other languages, then they're going to have mixed word predictions, and that's going to dampen the effect of our language model. We also picked users that were using the default keyword theme. If you've ever used Swiftkey, you might have noticed that we've got about 150 themes, and some of them are questionable, if you like, in terms of how they look. So that could have a really big impact on your typing experience. We didn't want that to happen in this environment. We also had picked users who'd been using Swifty for roughly the same amount of time. We didn't want to have a sample that had a new group, lots of users who've been on Swifty for years, and then another group of users who've been on Swifty for a few months and have less experience with the product. So there were over 500 users selected to take part in each of the testing groups. So participants didn't know which version of Swifty they were going to get. They didn't even know why they were being asked to test it. All they were told was that they would be testing a version of Swifty for 3 days, and after that 3-day period, they would be given a survey. And that survey is our chance to measure their attitudes based on those attributes that I mentioned earlier. And the metric was developed by a research lab that I worked in previously. So it's used to measure users' attitudes towards speech-driven and language-based interfaces such as the keyboard. So in this research, we were primarily interested in 3 different groups of attributes. So the first was usability. From the previous talk, you can see that any delay in performance, for example, can have a serious impact on user stress levels, the frustration with your app. You might find it harder to use. We were interested in performance itself because we know it has such a big impact on users' engagement. And of course, language quality. So we were interested in how users perceived the prediction and correction accuracy of the model that they were testing to see if there were any significant differences detected. So the survey had 16 attitude statements in total. An example of one of these is this version of Swifty offers me invalid word predictions in my language. And the users could rate to what extent they agreed or disagreed with each of the statements on a 7-point liking scale. So the results came back and we were quite shocked to see that in spite of what our internal testing tool had told us, users who tested the Engram model rated Swifty significantly better than users who had used Swifty with the mirror model. And the difference in the means, these scores are on a 7, was statistically significant. So once you detect a statistically significant difference in the overall means, you can then start looking at the different attributes that make up the questionnaire. So you can start to understand where which of the attributes are driving the difference, and you can see that most of the more favorable scores are settling on the side of the Engram model. We've got attributes, there were 10 of them, a total out of 16 that has statistically significant differences. So attributes like stress, frustration, feeling in control while using the product, and overall ease of use of the product. Users rated the neural network version significantly lower. Interestingly, the only 2 attributes that were significantly higher were those to do with prediction and correction quality. So it seems like this difference that we detected in our internal testing metric has manifested in market. However, there must be something else going wrong because users have rated our performance attributes significantly lower. So at this point in time, we knew that our model was better at predicting words, and users actually picked up on this. However, there's something underlying going on that we haven't actually been able to observe yet, and we feel like this is probably along the lines of performance. So whenever we designed the qualitative research, we wanted to bring users in and observe them using the product to see what further insights we could learn from that. So we need to find out what's going on, what's happening with the keyboard, why are users rating it significantly worse than the Engram model for performance. And what observational data could I gather that will help us identify the reason for that? So I've got some notes on observational data. So there are different ways that you can measure the observations that you make. There are simple observations where you can assign numerical data to what you see happening. So you've got things like when users are typing on the keyboard, you can count the words per minute and you can calculate the typing speed of words per minute. There's also behavioral observations. So while users were typing on both versions of SwiftKey, you could observe their behavioral reaction to what was happening, and you could see the frustration very, very quickly build to the point where at the end of the 60 minutes they didn't want to use the neural network version ever again. They didn't want to see it again. So we brought 12 existing SwiftKey users to come into the lab, and I recorded them typing for 60 minutes on both versions of SwiftKey. The main things that I recorded were typing speed on both versions of SwiftKey. That was measured points and words per minute. I observed personally if there was any visible lag or performance difference in the responsiveness of each keyboard, and I'll talk about how that is measured a bit later. And also any other comments that were made by participants, what their body language was like, their stress levels, that type of thing. So the main learnings from the qualitative research was that there was actually a noticeable lag in the neural version of the keyboard, and that was measured by calculating how long it took a word prediction to actually load on the keyboard itself in milliseconds. And this matches up quite nicely with what we saw in the quantitative phase. So users' stress levels rising, their frustration levels were higher whenever they were using the neural network version. But now we have video footage of that happening, and we have footage of exactly why it may have happened. And the next word predictions were more accurate on the neural network version, so we could confirm that from observing people typing on the keyboard in-house, which is good. And that matched up with the quant data that we collected, where users could feel the difference. So the result of combining these insights was a single message to our engineering team. So whenever we conduct research, we'll invite all of our stakeholders to come and have a look at the videos we've made, have a look at the report we've written, and we'll share and watch and discuss together what's happened. And often I'll have made numeric observations, and the engineers will be able to turn that into, oh, there might be a bug with something that I've done or something that someone else has done. Let's go take this video footage away and have a look at it. So we identify and reproduce bugs with the footage that we collect. We could then use that footage to improve the overall performance by fixing them, and then also validate the fixes against the original footage and the original testing that happened. So what have we done? So from our internal testing tools that we learned that the neural network language models were better at predicting next words. However, it was a quantitative research that taught us that users could detect an improvement in the language, but there was a significant negative impact on performance. And then when we brought them in, conducted some qualitative research, that really helped us pinpoint the cause of the negative performance issues. That allowed us to have video footage that would let us reproduce them and then validate if they were fixed. So over time we've repeated this process and refined the process, but we've also invested in better internal tool suites for measuring performance so that we might be able to detect these things earlier. But we still use these internal testing tools along with UX research to unlock additional insights that we wouldn't get from the tools or from the market whenever we release the product. I welcome any questions.
Any questions? So, yes. Well,
I'm going to ask a performance question. Surprising. Did you find solutions, and have you gone to the neural network approach now? So
yeah, so it took maybe 2 or 3 more iterations of finding bugs, fixing them, remeasuring, and just refinement over 2 or 3 cycles. But then we did eventually launch not just the neural network for English, but other languages as well.
awesome, cool, thanks.
any more questions? Yes.
Yeah, thanks, very interesting. Obviously, the approach you've suggested would be good for a company with a lot of resources behind it. Would you have any suggestions for someone who's just sort of a one-man hobbyist developer gathering this kind of information?
Definitely, we often kind of fall into the trap of not trying our own things ourselves and just simply observing other people using our products. So one thing that we've encouraged our engineers to do here is take some time to speak to other people about the work that they're doing, show them what they've done, and we'll provide them with a way of collecting meaningful feedback on that. So it could be making observations of what's happening, measuring the time it's taken users to complete tasks, whether they pass or fail the task. So is the user interface friendly, and does it offer the user a way of completing the task they want to complete? So yeah, I think speaking to anyone really is a good start. That's something you can really quickly get some insights from 5 or 6 people and uncover quite a lot of usability problems just by doing that.
Thank you.
Thanks. One more.
Hi, thanks for the talk. So during the quantity phase, how did you guys exactly measure stress or enjoyment of the user? Was that just purely based on questionnaires, or did you use any other techniques?
So during the quantitative phase, it was purely based on that questionnaire, and each of the attitude statements were written in such a way that you could express a sense of agreement or disagreement. So for stress, the particular question that we used was, I felt under stress while using this person's cookie. So then there's the 7-point likelihood scale where you could say, no, strongly disagree, it's fine, or yeah, I strongly agree. It wasn't measured in any other way other than the user's perception, if you like.
Thanks.
Right, anyone else? Here?
Was the plan to always do both the qualitative and the quantitative testing, or was you not bothered with either one? Have the initial survey showed that users agree with your gut feel that your network-based algorithm is better?
I think it would have depended on the results. So the first time we did this, it was just a blind run. It was just a best guess, if you like. And the approach that we took after that was based on the results that we got back. So the original plan was to run a quantitative experiment and see what that would bring back first, because it was data that we didn't have. And because it did lean quite heavily towards performance, we felt like the best follow-up for that was to bring people in and make observations. And if some of the other attributes had different scores, then our approach might have been different, but it's kind of a learn as you go approach. Yeah.
Thank you.
Cool. Last one?
When you're measuring typing speed, not in the lab, but just like when people are using their own like personal devices, how do you like deal with like someone basically using the phone and then just like minimizing to use another app or something like that? How do you guarantee that you're still actually measuring like accurate typing speed? Basically?
It's a really good question. I think that is exactly why we did it whenever we brought people in, because we could control the environment that they were in to a certain extent where it was still relatively similar to a typing session that could have happened on the train or at home, but without any other background noise that could happen, so Facebook notifications coming through, or you need to give up and do something else. So the measurements that we used in this experiment were purely collected in the lab so that we can control all the other potential confounding variables. So I would imagine that if we did something like that in the wild, we would probably have to collect that over a significant period of time and factor in these things that happen and have a sort of balanced measurement for a person in general over a longer period of time.
Yeah, no, it just becomes like an anomaly that just like washes out.
Yeah.
Okay, thank you.
Okay, cool. So that's it for us for tonight. I want to thank Microsoft for having us in this very good video. I want to thank both of the speakers, Doug and Simon, for their talks. And I also want to thank you for coming, because this won't be even possible without you. So thanks for coming to Roderick, and see you next month, right? Now there are still some drinks out there, some food, so you're welcome to stay until 9:30, I think, more or less, and enjoy. Yeah?